What if I told you that Earth having two suns wouldn't just mean brighter days and no nighttime? It would completely reshape our planet's climate, create impossible weather patterns, and potentially make life as we know it impossible. The reality is far more extreme than most people imagine. In the next 15 minutes, I'm going to show you exactly what would happen if Earth orbited in a binary star system, from the mind-bending physics to the catastrophic effects on our atmosphere, and why planets like Tatooine from Star Wars are actually scientifically fascinating but terrifying places to live. Welcome back, and today we're diving into one of the most captivating what-if scenarios in astronomy. What if Earth had two suns? This isn't just science fiction. Binary star systems are incredibly common in our universe, with nearly half of all star systems containing multiple stars. If you're fascinated by space science, planetary astronomy, binary star systems, or just love mind-bending what-if scenarios, make sure to hit that subscribe button because we're about to explore some truly incredible cosmic possibilities. Here's what we'll cover. First, I'll explain how binary star systems actually work and the different types that exist. Then we'll explore what would happen to Earth's orbit, climate, and seasons in a two-sun system. We'll examine the effects on our atmosphere, weather patterns, and most importantly, whether life could survive. Finally, we'll look at real planets that actually orbit two stars and what we've learned from studying them. Let's blast off into this cosmic thought experiment. Before we dive into what would happen to Earth, we need to understand how binary star systems actually work in reality. Binary stars aren't just two suns randomly floating in space. They're gravitationally bound systems that follow precise orbital mechanics. There are three main types of binary star systems that could potentially host planets. First, we have close binary systems where two stars orbit each other at distances similar to planets in our solar system. These create extremely dynamic gravitational environments that make stable planetary orbits nearly impossible. Second, there are wide binary systems where the stars are separated by hundreds or thousands of astronomical units. That's hundreds of times the distance from Earth to our Sun. In these systems, a planet could potentially orbit one star, while the other appears as just a very bright star in the sky. Third, and most relevant to our scenario, are intermediate binary systems, where the stars are separated by distances that would allow a planet to orbit both stars in a stable configuration. This is called a circumbinary orbit, and it's exactly what we see in science fiction with planets like Tatooine. For Earth to have two suns, in the dramatic sense we're imagining, where both stars significantly affect our planet, we'd need to be in a circumbinary orbit around two stars that are relatively close to each other, probably separated by a distance similar to the orbit of Mars or Jupiter in our solar system. But here's where the physics gets really interesting and really complicated. Unlike our current stable orbit around a single star, a planet orbiting two stars experiences constantly changing gravitational forces. The combined gravity of both stars creates what astronomers call a gravitational resonance zone, where stable orbits can exist, but they're much more complex than our simple elliptical orbit around the Sun. Now let's explore what would actually happen to Earth if it suddenly found itself orbiting two suns. The first and most obvious change would be to our day-night cycle, but the reality is far more complex than just more daylight. In a typical binary star system, where Earth could maintain a stable orbit, we wouldn't always see both suns in the sky simultaneously. The orbital mechanics would create fascinating patterns, where sometimes we'd see one sun, sometimes both, and occasionally we might experience what's called a double sunset, where one sun sets while the other remains visible. The length of our day would become incredibly variable. Instead of our current 24-hour day-night cycle, we might experience periods of continuous daylight lasting weeks or months, followed by periods where we have more traditional day-night cycles with only one sun visible, and then periods of reduced lighting when both suns are on the same side of our orbit. But here's where things get really extreme. The amount of energy Earth receives would vary dramatically throughout our orbit. During periods when both stars are visible and relatively close to us in our orbital path, Earth could receive twice or even 3 times the solar energy we currently get from our single sun. During other parts of our orbit, we might receive significantly less energy than we do now. This variable energy input would create absolutely catastrophic climate effects. Our current climate system depends on relatively consistent solar energy input, with seasonal variations of only about 6% due to our elliptical orbit. In a binary system, we could see energy variations of 200% or more throughout our orbital period. The temperature swings would be beyond anything life on Earth has ever experienced. During high-energy periods, global temperatures could soar to over 80 degrees 176 degrees, hot enough to boil away our oceans. During low-energy periods, temperatures could plummet to 40 degrees or lower, freezing the entire planet solid. Let's dive deeper into the atmospheric and weather effects, because this is where the scenario becomes truly mind-boggling. Earth's atmosphere and weather systems are incredibly sensitive to energy input, and the extreme variations in a binary star system would create weather patterns unlike anything we can imagine. During high-energy periods when both suns are pumping massive amounts of energy into our atmosphere, we'd see hypercanes, hurricanes with wind speeds exceeding 100 kilometers per hour. These storms would be powerful enough to level mountains and reshape continents. The extreme heating would cause massive atmospheric expansion, potentially causing some of our atmosphere to escape into space. The water cycle would become completely chaotic. During high-energy periods, evaporation would be so intense that we'd have continuous violent thunderstorms covering the entire planet. Lightning would be near constant, and rainfall would be measured in meters per hour rather than millimeters. During low-energy periods, the opposite extreme would occur. Water vapor would freeze out of the atmosphere, creating global snowstorms that could bury the entire planet under kilometers of ice. The atmospheric pressure would drop dramatically as gases condense, making it difficult for any remaining life to survive. But perhaps most fascinating and terrifying are the tide effects. Our current ocean tides are caused by the moon's gravity, with some influence from the sun. In a binary star system, we'd have 2 massive stellar objects constantly changing their gravitational influence on Earth's oceans. The result would be megatides that could be hundreds of meters high, constantly shifting as the gravitational forces change. Coastal areas would be uninhabitable, and the constant movement of these massive water masses would generate earthquake-like seismic activity on a global scale. The magnetic effects would also be extreme. Binary stars often have complex magnetic field interactions, and these could severely disrupt Earth's magnetic field. Without a stable magnetic field, our atmosphere would be exposed to deadly solar radiation from both stars, potentially stripping away our protective atmosphere over thousands of years. Now let's address the big question: could life survive on Earth in a binary star system? The short answer is that complex life as we know it would almost certainly be impossible, but let's examine why and whether any forms of life might adapt to such extreme conditions. Current life on Earth depends on relatively stable temperatures, consistent day-night cycles, and predictable seasonal patterns. The extreme temperature swings in a binary system, from potentially over 80 degrees to 40 degrees or lower, would make it impossible for most biological processes to function. Water, which is essential for all known forms of life, would constantly cycle between being a superheated vapor and solid ice. The brief periods when liquid water might exist would be during the transition phases, but these would be accompanied by violent weather that would make stable ecosystems impossible. The radiation environment would also be deadly. Binary star systems often produce more high-energy radiation, including X-rays and ultraviolet light. Combined with the potential disruption of Earth's magnetic field, the surface would be bathed in lethal radiation levels during high-energy periods. However, some extremophile organisms might potentially survive in very specific environments. Deep underground ecosystems, similar to those we find near volcanic vents on Earth, might be buffered from the extreme surface conditions. These life forms would need to survive on chemical energy rather than solar energy, and they'd need to be incredibly hardy. Interestingly, some scientists theorize that life might actually be more likely to develop during the brief habitable periods in such systems, the transition times when temperatures are moderate and liquid water exists. But this life would need to be incredibly adaptive and probably very different from Earth life. The evolutionary pressure in such an environment would be intense. Any surviving organisms would need to rapidly adapt to extreme temperature changes, radiation exposure, and constantly changing atmospheric conditions. This might actually accelerate evolution in fascinating ways, potentially creating life forms with abilities we can barely imagine. Let's examine real planets that actually orbit two stars, because these aren't just theoretical. We've discovered several of these amazing worlds, and they teach us a lot about what binary planet systems are actually like. The first confirmed circumbinary planet was Kepler-16b, discovered in 2011. This planet, nicknamed Tatooine after the famous Star Wars planet, orbits two stars every 229 Earth days. The two stars orbit each other every 41 days, creating a complex gravitational dance. Kepler-16b is a gas giant about the size of Saturn, and it's too cold to support liquid water, receiving only about 1/3 the energy that Earth gets from the Sun. But what's fascinating is that it experiences dramatic temperature variations as its orbit takes it closer to and farther from the binary star pair. Another remarkable example is Kepler-47c, which orbits in the habitable zone of its binary star system. This means that if it were a rocky planet with the right atmosphere, it could potentially have liquid water. However, it's also likely a gas giant, so any moons it might have would be the more interesting candidates for life. These real examples teach us several important lessons. First, stable orbits around binary stars are possible, but they require very specific conditions. The planets we've found tend to orbit relatively far from their stars, in regions where the gravitational influences are more stable. Second, the energy these planets receive varies much more dramatically than what Earth experiences. Kepler-16b's energy input varies by about 20% throughout its orbit, which is already much more extreme than Earth's 6% variation. Third, most of the planets we've found in binary systems are gas giants, not rocky planets like Earth. This might be because rocky planets have a harder time forming stable orbits in the chaotic early stages of binary star system formation, or it might just be an observational bias since gas giants are easier to detect. What's really exciting is that we're discovering more of these systems all the time. As our detection methods improve, we're finding that circumbinary planets might be more common than we initially thought, giving us more examples to study and understand these extreme environments. From an engineering and physics perspective, The scenario of Earth having two suns reveals just how precisely calibrated our current solar system is for supporting life. The stability of our single star system, our nearly circular orbit, and the consistent energy input we receive are actually quite rare and remarkable cosmic conditions. If we wanted to engineer a habitable planet in a binary star system, we'd need to solve several enormous challenges. First, we'd need to find or create a stable orbital zone where temperature variations are minimized. This might require a very specific distance from the binary pair and possibly a highly elliptical orbit timed to avoid the highest energy periods. Second, we'd need robust atmospheric engineering. The planet would require a thick atmosphere capable of buffering extreme temperature changes and protecting against radiation. This might mean an atmosphere several times thicker than Earth's, possibly with unique chemical compositions we don't see in our solar system. Third, we'd need to solve the water stability problem. This might require subsurface oceans or specially engineered surface conditions that keep water liquid through the extreme temperature cycles. From a colonization perspective, humans living in a binary star system would need incredible technology. Underground cities would be essential to protect against radiation and temperature extremes. Energy storage systems would need to capture and store the massive energy inputs during high energy periods to sustain life during low energy periods. The psychological effects on humans would also be extreme. The constantly changing lighting conditions, unpredictable day-night cycles, and knowledge of the hostile environment outside would create unprecedented mental health challenges. However, the energy resources available during high energy periods would be enormous. A civilization that could harness and store this energy might become incredibly advanced, using the extreme conditions to their advantage for manufacturing, computation, or space exploration. Looking at this thought experiment from a broader cosmic perspective, it highlights just how special Earth's conditions really are. The scenario of Earth having two suns isn't just about brighter days or no nighttime. It's about fundamental changes to physics, chemistry, and biology that would reshape everything about our planet. Binary star systems are incredibly common in the universe, making up nearly half of all stellar systems. This means that if intelligent life exists elsewhere, much of it might have evolved under these extreme variable conditions. Alien civilizations from binary star systems might be far more adaptable and technologically advanced than us, having been forced to develop solutions to survive in chaotic environments. The study of binary planet systems also helps us understand planetary formation and evolution. These extreme environments serve as natural laboratories for testing our understanding of atmospheric dynamics, orbital mechanics, and astrobiology. For Earth's future, this thought experiment reminds us how dependent we are on our sun's stability and consistency. Even small changes to our solar energy input could have catastrophic effects on our climate and civilization. It also highlights the importance of developing technologies for extreme environment survival. Whether for exploring other planets, surviving climate change, or preparing for cosmic disasters, the challenges of surviving in a binary star system represent the ultimate test of our technological and biological adaptability. What if Earth had two suns? The reality would be far more extreme and fascinating than most science fiction imagines. We wouldn't just have brighter days and dramatic sunsets. We'd have a planet with catastrophic climate swings, impossible weather patterns, deadly radiation exposure, and conditions that would make complex life nearly impossible. The temperature extremes alone, potentially ranging from over 80 degrees to 40 degrees, would create an environment more hostile than any place on Earth today. The atmospheric chaos, megatides, and magnetic field disruption would reshape our planet beyond recognition. Yet this thought experiment reveals the incredible precision and rarity of Earth's current conditions. Our single star system, stable orbit, and consistent energy input represent a cosmic sweet spot that allows for the complex, stable ecosystems we depend on. While life might theoretically adapt to binary star conditions, it would be fundamentally different from Earth life, possibly limited to underground extremophiles or highly adaptive organisms unlike anything we know. The discovery of real planets orbiting binary stars like Kepler-16b and Kepler-47c shows us that these systems exist and can be stable, but they also confirm just how extreme and variable these environments really are. For humanity, this scenario reminds us both of our cosmic fragility and our incredible adaptability. While we couldn't survive Earth having two suns without advanced technology, the challenge of imagining such survival pushes us to develop better understanding of planetary science, atmospheric engineering, and extreme environment technologies. If you found this cosmic thought experiment as fascinating as I did, make sure to like this video and subscribe for more space science and what-if scenarios. What do you think? Could any form of life adapt to a binary star system? Would you want to visit a planet with two suns, even with all the extreme conditions? And what other cosmic scenarios would you like to see explored? Let me know your thoughts in the comments below. And if you enjoyed this deep dive into binary star physics, hit that notification bell so you don't miss our upcoming videos on other extreme cosmic environments. Thanks for joining me on this journey to imagine Earth with two suns. Until next time, keep looking up and wondering about the incredible universe around us.